Hi. So now we're going to tackle about taking limits algebraically when we do not have graphs. So how can we find out the behavior of functions, especially when they increase manifold positively or negatively, but without a graph to look at? Okay. Now, before we uh, begin treating that subject, we have to first go about understanding the concept of a signed zero. All right, so let's have this. A signed zero, okay, a signed zero is a concept, zero plus or zero minus. Typically, we use these notations, zero plus or zero minus. Now, this means, okay, what they mean only is this. When we say 0 plus, these are very small numbers. Think of 0.00000000001. Very small. Now, when we say 0 plus, okay, we are talking about very small numbers that are nonetheless positive. So for example, this number here, which has 9 leading zeros, okay, this is a very small number, sometimes already negligible. Nonetheless, it is positive. Now, the repercussion of this is that when you divide a number, say for example 5, divided by this small but nonetheless positive number, you will get a very large number. You will get a very large number or positive infinity. Again, when you divide a positive number by a very small but nonetheless positive number, you will get positive infinity. However, if you have a negative number, say negative 8, and you divide that by a very small but nonetheless positive number, you will get this time a very large negative number. You will get a very large negative number. You can use your scientific calculator right now to confirm our results. Okay. Will dividing 5 by this very small number that has 9 leading zeros, or will it result to positive infinity? And will dividing negative 8 with this small but nonetheless positive number result into negative infinity? The result, though, is that this. We can generalize this. When you have a positive number by a 0 plus, you get positive infinity. And when you have a negative number by a 0 plus, you get negative infinity. Okay? We have this general case. Now, what about 0 minus? Okay, so this is the case of 0 plus. What about 0 minus? 0 minus are, again, very small numbers, practically negligible. We can already neglect them. Nonetheless, it carries a sign. All right, we are thinking probably negative 0 point, again, 0, 0, 0. Huwag natin masyadong OA-han. Okay, 0, 0, 1. Yan lang. Okay. We have this, again, very small number with 5 leading zeros. But the crucial thing is it is negative. Okay? That's the crucial thing. It is negative. So, if you're going to do the division, say for example, I have a number 2 divided by a very small negative number. So because I have 2, positive 2 divided by a very small negative number, I will end up with a large negative number. A large negative number. And if I have, for example, negative 10 divided by 0 minus, okay, a very small but nonetheless negative number, I will get a large positive quotient. Why? Okay, because we can generalize that also. A positive number divided by a negative small number will get me negative infinity, and a negative number divided by a very small negative number will get me positive infinity. All right, so that's for our introduction. We will go to solving problems after this. Okay, so we have these problems. Let's begin. Sir, I have the limit of the rational function 2x over x plus 8 as x approaches negative 8 from the right. All right. So first, you have to do substitution. Again, that's our first resort. When we have a limit problem, we first do substitution. If it works, then we're good to go. So we have 2 times negative 8 divided by, okay, this is the crucial thing. We have negative 8 plus 8. Sir, what is that? All right. Okay. Don't worry. Okay, don't worry. Uh, First, the numerator is quite easy. So this is just negative 16. Again, because negative 8 plus, if we multiply that with a constant, we can get practically negative 16. There's no need to overanalyze there. It's the denominator which we have to put attention, which have to give more attention to. Okay. Sir, what is negative 8 from the right plus 8? Okay, children, we have to, if you want to make your life easier, imagine, okay, put a face to this number. Give me a negative 8 plus. Sir, we can think of probably negative 7.9999. Okay? Because basically we are looking at numbers close to negative 8, but to the right of it, greater than negative 8. So, can be negative 7.99959. All right? Now, this is much easier. Okay, life is now easier. Why? Because when you have negative 7.99999 and you add 8 to that, which is obviously larger, you will get a number close to 0 but positive. Okay? You can take out your calculators right now and check whether what I'm saying is true. Okay? But okay, it's very easy. It's very easy to look at that. Negative 7.59 plus 8 will give you a very small number, but nonetheless positive. But nonetheless positive. So to continue, so the denominator is 0 plus. So from our initial from our introduction earlier, we know that this is a negative number, negative 16, divided by a number very small but is nonetheless positive, gives us negative infinity. So sir, ibig sabihin lamang yan, this function behaves such that to the right of negative 8, okay, the function goes to negative infinity, or it increases manifold, but negatively. But negatively. Nakuha. Okay, sige. If not, let's go to the next example. Baka naman mas makuha ninyo. All right. Now you have limit of 4 divided by x minus 7 quantity squared. Okay. If we are going to do substitution right away, remember you will get 4 divided by 7 minus 7 and then squared. Unfortunately for us, this is 4 all over 0 squared. We cannot get any description from this, okay? Because this is undefined, okay? This is undefined because 4 divided by exactly 0. If it were like earlier, na 0 minus or 0 plus, then we could have at least a description of how the function behaves. But this is exactly 0. So for now, we don't have any idea how this function behaves. But what we can do is do you remember earlier we had, sir, we can actually investigate the behavior of a function at exactly a certain xa if we check the left and the right hand limits, correct? So let's take, for example, let's check first the left hand limit, okay? Now, let's check the left hand limit and see if they agree with the right hand limit. So let's check the left hand limit first. All right, so we have the limit of, okay, so we have 4 over x minus 7 squared as x approaches 7 from the left. Okay. Let's check that first. Okay. Limit of 4 over x minus 7 as x approaches 7 from the left. Sir, that will give us 4 divided by 7 from the left minus 7 squared. All right. Sir, what is 7 from the left? So bigyan natin again, let's put a face to this number. What is 7 from the left? Uh, let's say 7 from the left, we are talking about 6.9999. All right. So we have this number. If we are going to subtract 7 from this number, we will get 4 over 0 minus, right? Because this is smaller than 7. So if you're going to take 7 away from it, then the result is very small but is negative. However, we have to square that. So imagine as a negative number squared. What happens to a negative number when it is squared? Sir, it becomes positive. Tama. A negative number when squared becomes positive. Oh, so that means, sir, that the left-hand limit, okay, the left-hand limit is positive infinity. All right. This means that the behavior of the function 4 over x minus 7 squared as x approaches 7 from the left is positive infinity. Now let's examine the right-hand limit. Sir, that is the limit of 4 over x minus 7 squared as x approaches 7 from the right. Okay, so now we are talking about 7 from the right. Let's put a face. Let's put a face to that number. Uh, let's say we are talking about 7.0000001. Okay. Now, it is very clear that when you subtract 7 from this number, 7 plus minus 7 gives you, okay, a small but nonetheless positive number and then squared. Okay, don't forget you have to square. Okay, so you have a small positive number and you square that, you still get a small positive number. Diba? So that means this is 4 over 0 plus. Kasi nga, we are squaring a positive number, even if it's small. So, sir, that means also that it is positive infinity. Uy, sir, I remember from our previous lessons that when the left and the right hand limits agree, then we can conclude. Therefore, the limit, since, okay, the limit of f, or, yeah, let me just, sorry, let me rewrite that. Okay, since the limit of 4 over x minus 7 squared as x approaches 7 from the left is equal to the limit of 4 over x minus 7 squared as x approaches 7 from the right, since they are equal, then we can conclude then the limit of 4 over x minus 7 squared as x approaches 7 is positive infinity. Again, what we used is to first investigate what is the left-hand limit and also the right-hand limit. It so happened that the two of them agreed, and therefore the limit of the function as x approaches exactly 7 is positive infinity. Okay, now let's have another example. Sir, what about this? The limit of 2 divided by cube root of x as x approaches 0 from the left. Sir, let's see. By direct substitution, we get 2 divided by cube root of a 0 minus. Okay. So, di ko ma-imagine. Don't worry. Okay, then put a face to this number. Let 0 minus be negative 0.00000001. It's a negative number. If you take the cube root of a negative number, you still get a negative number. Diba? If you recall your seventh grade algebra, taking the cube root of a negative number still gives you a negative number. This means that this is 2 over a small but nonetheless negative number. So then that's easy, sir. This is negative infinity. All right, correct. Now, how about this one? Sir, it's almost the same, but this time 0 plus. Okay, so by direct substitution, we get 2 divided by the cube root of 0 plus. So, di ko ma-imagine ulit. Let's give a face to this. 0 plus is not equal. Let's estimate that to be 0.0000000001. All right, very small, but nonetheless positive. Now, when you get the cube root of a positive number, you still get a positive number. Again, the cube root of a positive number is still a positive number. So the cube root of this small but nonetheless positive number is still positive. So you have 2 over a positive number but very small. This gives you positive infinity. Now, if I ask additionally, okay, so hindi na to part ng exercise, but what if I ask, so what is the limit of 2 over cube root x as x approaches 0? Okay, not left, not right, just 0. Unfortunately, okay, so our answer to this is that unfortunately, the limit of 2 over the cube root of x as x approaches 0 from the left is not equal to the limit of 2 over the cube root of x as x approaches 0 from the right. Therefore, our answer to this is does not exist because the left hand limit and the right hand limits okay, are not in agreement. The left hand and the right hand limits are not in agreement. But we do get at least some descriptions. With these results, we get some descriptions about how the function behaves, how the function 2 over cube root of x behaves as we approach, as x approaches 0, whether from the left or from the right. Okay, they increase manifold, okay, one negatively and the other positively. All right, so that's all for now. See you next time.